Home coffee roasting is a great hobby. It's a lot of fun, but there is a learning curve. We've been going through a lot of different topics here discussing how to roast great coffee at home. And today's video focuses on the charge temperature when we begin the roasting process. So stick around. All right, thank you so much for joining me today, and welcome to the Virtual Coffee Lab. Roasting coffee at home isn't without its challenges. There's a lot of different elements to roasting to help us roast great coffee, and we can do that. It's just a matter of following some really basic principles when it comes to roasting coffee. We just finished up the development phase of coffee roasting in last week's video, and that was part of a series of really 4 videos, an introductory video and then 3 videos, one on each of the 3 phases of coffee roasting. I would really encourage you to check that series out if you haven't seen it yet. It's really important. So I want to circle back and I want to talk today about the charge temperature for the roasting process. The charge temperature is the initial temperature of the roasting environment when the roasting process begins. Some of us have drum roasters, some of us have hot air popcorn poppers, some are using a flame and a frying pan, and there's other different hybrid types of roasters that are being used. So when I share these concepts, just imagine and try to work through how that might apply to you. It does apply to every coffee roaster that's roasting coffee at home. So how does that temperature impact the rest of the roast? How does that impact really the profile that we're trying to achieve? We're going to try to address those questions and really take a bigger picture, a better understanding of really the choices that we have and the impact that they'll have as we roast. And the best way to do that is an analogy. Imagine a roller coaster. You get in the roller coaster, the ride begins, and you are pulled up a large steep incline to this very high point, probably the highest point of the ride. At that point, the mechanism disengages from the roller coaster, and the rest of the ride, to get to the end of the roller coaster ride, is dependent on momentum. It's dependent on gravity and the amount of momentum, and that's how much weight is in the roller coaster, how steep the ride, the descent is to be able to get over, and how much speed is built up to be able to get over the next hill. So we have a hill that we need to get over, and that will kind of determine the speed of the descent on our ride, which is coffee roasting. So the dry phase, when we charge the roaster with the coffee, all the way till the point when the coffee is dry, and we say that it's dry, and we know that it's dry because the beans have gone from green to a yellow color. That dry phase is the ride up the roller coaster top. That is when we are more or less determining the height of the ride that will determine the speed and the momentum of the rest of the ride, which is the roast. So I'm really dragging this analogy out, but I hope that it draws a picture for you guys, because depending upon how aggressive you are with your charge temperature, that will determine how long or short your other phases are. That will determine whether you have roasting defects in your coffee. That will determine whether you'll have enough momentum to make it through your roast without crashing your roast or having your coffee bake. Those are all really, really important points that I hope that you have understood as we talk about the charge temperature and this momentum that we're trying to, or this energy that we're trying to build up. And that's really what's happening. We have to have an idea of how our roaster performs so that we know how much time it's going to take for us to get to the top of the ride, to get to the top, or to get to dry end. So what is the temperature that we should use? The answer is that it all depends upon so many different factors. It depends upon the roasting equipment you're using. It depends upon what the capability of that roaster is as far as energy, BTUs, how much heat you can apply to get that roasting environment temperature up so that the beans will get through this dry phase within a certain period of time. If you want to know more about the dry phase, I mentioned in that video the dry phase is probably the most important phase of coffee roasting. Actually, I said it is the most important phase of coffee roasting because it's going to set you up for success or failure. It's going to determine what happens with the rest of the roast. So the charge temperature is really the master mechanism. It's the thing that is going to determine whether your dry phase will be successful or not. So let's talk about the impact of the charge temperature and how to know what charge temperature to pick when we start our roasting process. Okay, so let's say that we use a charge temperature of 400 degrees. There are several things that we need to think about when we choose a charge temperature. We're using 400 degrees as just a simple starting point for a conversation here. It's not a temperature you should or shouldn't use. We just need to have something to talk about. All of our roasting environments are different. Our roasters are different. Our probes are different. So one of the things you risk when you choose a charge temperature are roasting defects. I did a whole video on roasting defects. You should check that out because we deal with scorching, tipping, we deal with baked coffee, all of the things that are going to be impacted by this charge temperature ultimately are in that video. But what's going to happen is that this 400 degrees that we are starting with on our test roast here, we're going to see if that is going to be able to get us from the minute that the beans enter the roasting environment up to dry end within a certain period of time. In order for us to do that, we have to have enough energy at the starting point to get us through that phase in 5 minutes. So, will 400 degrees do that on your roaster? If your roaster is set for 400 degrees, you leave the heat on, you charge the roaster with the beans, will your beans be dry in 5 minutes? So that's the question. Now, I'm using 5 minutes as the example, but the reality is that some roasters can't do that. Some equipment can't do that. It's going to take 6 minutes or 7 minutes or whatever time that is. That's irrelevant as long as you're able to get those beans through this first phase in a relatively short period of time, the quickest time possible that you could, without causing roasting defects and without having too much momentum, without going up the hill so fast that you're so high that when you start to come down, you are just going to fly too fast through the rest of the roast. I'm trying to stick with this roller coaster analogy. I'm not sure. I think it'll work through this entire roasting process here in this example. But let's say that 400 degrees is too fast. You went through the dry phase in 3.5 minutes. You got some roasting defects. You saw tipping and scorching. It was just too hot. Well, then you should lower your roasting environment. Let's just say, if you want, say 20 degrees, okay, or whatever that is in Celsius, and then try it again, and then see how your roaster behaves, how it performs. Once you've determined how your roaster performs, then you can start to get creative and you can start to make different types of changes. So I'll give you an example of that. I know how my roaster performs. I know how much heat that I am going to be applying during the dry phase in order for me to get to my dry end temperature and time that I desire. So that when I charge the roaster, I'm charging it, the beans are going in, but my flame is not on. I've turned my flame off at the temperature that I am at, and I put my beans in the roaster. The gas is then turned off, and I wait a period of time because I know in my roasting environment, I have enough momentum where I can use this gas off environment as a safety net to make sure that I don't have roasting defects take place in my roast. So you might already be aware of that. You might not be aware of that. It's called soaking your beans. So some people soak, some people don't soak their beans. I will soak my beans anywhere from 30 seconds to 1 minute. I've even gone longer depending upon the type of coffee. And I base that on the density of the coffee and the size of the bean. Those are the two big variables for me to determine how long I want to soak my beans. So if I choose 400 degrees on my roaster, my beans go in, my gas is off for 30 seconds, and then I turn my gas on, and the bean temperature is increasing, and the dry phase will end within 5 minutes. That's how it works for me. You'll have to experiment to see how that works for you. So that's the first thing you should be thinking about, is what is the capability of my roaster and how is that going to impact my dry phase time. And ultimately, if you do that first step right, the momentum and the rest of your roast, the pace of your roast, is just all going to fall in place. But if you choose too low of a charge temperature, then the 5 minute target that you're trying gets stretched out to 6-7 minutes. Then what happens is, I did this, I actually made this mistake, and I did this during the dry phase video that I did. Why is the dry phase so important? I actually messed up my roast because my charge temperature was off just a few degrees, but my soak was too long. And then because I wasn't paying attention, I was talking, wasn't paying attention. And then when I started the roaster gas, it took me longer. That roller coaster climb up got a lot slower, and the hill was just as long, but it just took me longer to get up to the top of the hill. And then what happened was, because I had increased my gas higher than I normally do to try to catch up, the momentum that I had at the top of the hill, basically at dry end, that momentum basically shot me through my roast too quickly, and I didn't have a successful roast. When you've made that mistake, then you're going to be making all kinds of other adjustments to try to compensate, and all of those adjustments are just going to complicate. It's basically the wheels falling off the car. It's just basically it's the meteor that is going through the Earth's atmosphere, and basically chunks of it are falling off. That's kind of my picture of a roast that starts to fall apart. So yeah, the charge temperature is really important. And if you choose too low of a charge temperature, it is a setup for disaster. If you choose too high of a charge temperature, it's the same thing. So you're going to need to experiment to be able to find the right charge temperature, and you're going to have to make a few different roasts to kind of find that equilibrium, that happy space. And then, depending upon the coffee, once you've got that number, let's just say it's 400 degrees in this example, then when you choose different coffees, you're going to adjust that temperature slightly, maybe 10 degrees difference either way, maybe a little more, maybe a little less, based on maybe if it's a dry process coffee, or maybe if it is a very large bean, or one that is a low density bean. And all of those are going to have an impact on how much heat you should apply. You know that a lower density bean is more prone to roast defects, and so you need to be a little more gentle with the heat, so a slightly lower charge temperature. And again, with all of this, after every roast or during every roast, you should be watching the beans, smelling the beans, and listening to the beans so that you can understand how these beans are being impacted by the heat. So even during the dry phase, you should be watching the beans. Do you see roast defects? as you are roasting this coffee. When you drop the beans out of the roaster and you take a look at your roast, look for roasting defects. That's going to tell you what happened during your dry phase and the charge temperature that you chose. So what else can we talk about related to charge temperature that really makes a difference, that's really going to set you up for success? One of the things we haven't talked about, which is kind of the elephant in the room, and some of you don't have this built into your roasters, but in this case, this roaster I do, and that is the exhaust temperature. If you're roasting on a drum roaster, then you'll have a probe that basically is monitoring your exhaust temperature. And you may or may not really know what that is for or how you can use it to your advantage. But the exhaust temperature is an indicator of how much energy you have in your roaster. The exhaust temperature is something that will tell you whether you've got enough momentum or not enough momentum to help you in your roast. So when I am setting up my roaster to charge my roaster, before my beans go into my roaster, I'm making sure on my roaster that I am roasting, I'm warming up my roaster so that the temperature is rising and that my exhaust temperature is higher, quite a bit higher than the bean temperature in the roaster. So I'm going to go with this example of 400 degrees for the charge temperature. My exhaust temperature may be closer to 475 or 500 degrees. That is going to allow me to soak my beans for 30 seconds so that I can let the beans adapt to this roasting environment, this hot air environment, and allow that energy to begin to penetrate without the risk or with the lower risk of roast defects, right? So exhaust temperatures can be used for a soak. Exhaust temperatures can also be used as a monitor for momentum. So when you get to dry end, if you've looked at any coffee graphs online, take a look. You'll see, usually it's like a dark blue line is your bean temperature, and you'll see that going up. And then you'll also see a red line that's above it that kind of stays above it, goes up, and then kind of levels off and then rides above the bean temperature. That exhaust temperature is if you're seeing that exhaust temperature be higher than your bean temperature, you're always going to have a positive, or generally speaking, you're going to have a positive rate of rise because you've got more energy in that system and your beans are trying to, and they're basically at some point they're going to meet where you've reached this towards the end of your roasting phase. Now, there are going to be adjustments in your gas, and so that exhaust temperature line that you see going across will begin to descend or will begin to lower. But that is something that I've been noticing, that I'm learning about. But start to watch your exhaust temperature and watch that red line and watch how that is influenced by your drum speed, by your gas changes, and then especially watch what happens during the charge temperature if you're doing a soak and not doing a soak, and also when you are going to drop your beans when the roast is ending. Take a look at that exhaust temperature. That is a real interesting topic. That's a real thing to talk about because there's different opinions. I've heard of people that roast basically using their exhaust temperature as a monitor to when they should be making changes in their roast. So that's a whole nother topic. It's one that I'm still trying to work through and figure out. But I use the exhaust temperature to help me with my soak and to help me monitor my momentum in the roast. And I suggest that you take a look at that and see what you learn monitoring your exhaust temperature. I would really be interested in hearing your thoughts on charge temperatures. You know, one of the things about this channel is that community and comments, conversation is really helpful for all of us. It's helpful for me as I roast. I've learned so many different things from people that have left comments, And I hope that my videos have helped you guys learn more about coffee roasting. And if they have helped you, I would encourage you to subscribe. You know, I get a chance to look at my statistics or my analytics in my channel here, and it's really interesting. Coffee roasters, you guys and girls, you're out here, you're looking for information, and some of you are taking time to ask questions and or share things, and that is huge. That's really helpful. But there's a large chunk of you that are watching the videos, and I'm not really sure, and I'd love to hear your feedback. I'm not really sure what you think of the videos. I think 70% of you watch the videos and you haven't subscribed. I would really encourage you to do that. If you like what you saw today in this video, hit the like button and hit that bell notification too, so you'll know the next time I upload a video. All right, last but not least, this momentum, there is a third point to my video here, and this momentum is really built up energy that you can use to your advantage with your airflow. And that is another element to why we want to choose the right charge temperature and why we want to have enough of this built up energy in this first phase of roasting that we can use the air to our advantage later on. That's not going to happen if we choose too low of a charge temperature. If we choose a charge temperature of 380 degrees and that's too low, and we're struggling to try to get through this first phase in this 5-minute example that I shared, you're not going to have enough energy built up to really be able to apply air to help set you into this next phase of roasting. And in my roasting style, I'm using air as a convection roasting device. I'm using air to help me apply more heat and more energy to help that bean absorb more energy, and I'm using air to do that. If you have too low of a charge temperature and you're behind, you're not going to be able to use air to your advantage until later on, and then you're going to have so much momentum when you start using that air, it's going to speed things up even more in your roast. And so the charge temperature is so important. It is so critical that you find and understand your roaster and its capabilities, and that you find what momentum you're going to need to get you from point A to point B, from charge to dry end, to set yourself up where you're at the target times and temperatures to begin the middle browning phase of your roasting without being too hot or too cool. The charge temperature, you guys, is one that will make or break your roast, and I'd like to hear your comments and your opinions and thoughts and experiences on charge temperature. I'd also really like to hear your thoughts on exhaust temperatures, and if you use your exhaust temperature as an indicator of the momentum, or how you use your exhaust temperatures. And if there are any of you that are using that as your primary way to monitor your roast, I'd love to hear about that too. That's really cool. I'd like to see how you're doing that or hear how you're doing that. So thank you so much for joining me today. I hope that this video has been helpful to you, and I hope you have a great week roasting.